Hello, in this video I will introduce the telescoping series and when to use the telescoping series test. So this is Calculus 2 and we are doing the telescoping series. So telescoping series test, the name describes what happens with partial sums. So there's a huge hint of when to use this method. Figure out if a series converges or diverges. So this test deals with partial fractions. So if you have any kind of partial fractions, that is a big hint that you're going to use this method, telescoping series. Um, so it's basically where the partial sums terms of the series cancels out. So only use this test when you are asked to find what a series converges to, otherwise choose another test. So the key word is if the question says what a series converges and it's in a partial fraction, uh, then you must use the telescoping series. Which test can you find with the series converges? So you have learned that geometric series is the first term over 1 minus ratio. And then you have the telescoping series. So basically these tests determines what a series converges to. So you have the GMX series, the telescoping series. So basically telescoping is whatever that hasn't been crossed out. And then you also have the Taylor Maclaurin. Maclaurin, can't even say it. But we haven't learned that, so we're not going to go over that. But it's good to know. So the Taylor Maclaurin series determines if it to find what it converges to. Okay, so let's start with an example one. Example one says, find what the infinite series converges to by using the telescoping series test. Now, they're not in the question, they're not going to be that nice to use. They'll say use telescoping series. You know that if they ask you to find what it converges to, that's a big clue that you know you already use telescoping. And also, is this a partial fraction? Well, is this? So we have the summation from n equals 1 to infinity of parentheses 1 over n minus 1 over n plus 2. Is this a partial fraction? Not yet. We're going to have to create some kind of partial fraction. So what I would do first is create some partial sums. So create some partial sums. So first I would just plug in 1. So let's do that. So that would be 1 over 1 minus 1 over 1 plus 2. And then I'm going to plug in 2, and I'm going to continue this process until stuff cancels. And then whatever is left over, yeah. So when I plugged in 1, this is what I get. Then I'm going to plug in 2, and when I plug in 2, I'm going to get, hold on, let me clean this up a bit. 1 over 1, and then 1, this is minus 1/3. And then if I plug in 2, this would be plus 1/2. Kind of do this in your head. 2 plus 2 is 4, so that would be 1/4. Oh, there's a minus, so this should be a minus 1/4. And then if I plug in 3, we're going to get 1/3 minus 3 plus 2 is 5, so that's minus 1/5. And then when I plug in 4, it would be 1/4, and then 4 plus 2 is 6. Why do I always put it should be a minus right in the middle? And then if I plug in 5, it would be 1/5 minus 5 plus 2 is 7. Okay, now this is what we got. Now, do you see anything that cancels? Yes. So wait, let me rewrite this again. So when we stopped at 5, plugged in 5, right? So when you do that, this is what you should get. Okay. So if we keep on going forever, it starts to cancel. So your answer is what left over. And what are you left over? You are left over with 1 plus 1/2. Yes. So if you keep on going, doing the process, you are left with 1 plus 1/2. And then if you do the summation, it would be, so your final answer will be 3/2 because 1 plus 1/2, 1 over 1 can be like 2 or 2. So that'd be like 3/2. So yeah, the final answer will be 3/2. Okay. Move on to example 2. Example 2 says, find what the infinite series converges to by using the telescoping series test. So we have 1 over n squared plus 4n plus 3, and uh, we got to break this down into some kind of partial fraction. So that's the first thing I would do is break this down or factor. So 1 over n squared plus 4n can be factored out as n plus 3 and n plus 1, right? Now we have to create some kind of partial fraction. So it would look like this. 1 over n plus 3, n plus 1 equals to a over n plus 3 plus b n plus 1. Okay. Now you got to get rid of the fraction by multiplying all three sides by the LCD, and our LCD is n plus 3 times n plus 1, right? So when you do that, you get 1 equals a times n plus 1 plus b times n plus 3. And then you do the partial fraction. So if I solve for n over here, if I set n plus 3 to 0, and then you solve for n, that would be n equals -3. And then if I plug in -3 into here, you're going to get 1 equals a. -3 plus 1 is -2, plus b, and then -3 plus 3 is 0. And you get 1 equals a times -2 is -2a. Solve for a by dividing both sides by -2. And I get a equals -1/2. Okay. Now we got to find what our b is. So now I'm going to substitute. Now I'm going to do the same process, but now I'm going to set n equals -1 because that'll get rid of my a and somehow solve for b, right? So I'm going to set n equals -1. So it's 1 equals a, and then replace n with -1. So -1 plus 1 plus b, and then n is -1, so -1 plus 3. So that's 1 equals, and then -1 plus 1 is 0, so a times 0 plus b, -1 plus 3 is +2. And what happens is you get 1 equals 2b, and then solve for b by dividing both sides by 2. So I get b equals 1/2. Okay, so our b is 1/2 and our a is what? -1/2. Now what we're going to do is put it back into our partial fraction. So we get so a is -1/2 over n plus 3 plus 1/2, b is 1/2 of over n plus 1. Then what you're going to do, you have this minus here, so you can put that in right in the middle. So you can rewrite this as the integral, the summation of n equals 1 to infinity. And now you have 1/2, positive 1/2 over n plus 1 minus 1/2 over n plus 3. And then what you could do next is, I guess you can factor out this 1/2. So it's going to be n equals 1 to infinity, and you get 1/2 parentheses 1 over n plus 1 minus 1 over n plus 3. Now you can telescope, because now we have it in a partial fraction, so now you can telescope. So just remember the first example, you plug in to telescope, you got to plug in some values and somehow they'll converge. So that's exactly what we're going to do here. So what we'll do is plug in 1. Okay, plug in 1 back into here. So you're going to get 1/2 minus 1/4. And then if you plug in 2, you get 1/3 minus 1/5. And then when you plug in 3, and then when you plug in 4, and then when you plug in 5, it converges to this. That would be your final. Okay, and then so that is introduction to telescoping series. So it must be in a partial fraction form, and basically it's whatever left over is your answer. And the clue is they ask you to if the question asks you what number does it converges to, that's a good chance you'll be using telescoping series. Okay. The next series or another uh, test would be alternating series test, and we'll go over that in the next video.